Welcome to This Explainer. I'm absolutely thrilled you're here today because we're taking something that usually feels like a total black box, our local power systems, and we're literally tearing the lid right off. Seriously, if you've ever stared up at a power line and thought, how does all that electricity actually get managed? Well, you're exactly in the right place. Today we're going to decode the operational logic of microgrids. We're looking at this through the eyes of a power systems engineer, but don't worry, we're keeping it completely accessible and honestly, incredibly fascinating. So, what if your community could literally become its own power plant? Think about that for a second. For over a century, our default setting has just been complete reliance on the massive traditional utility grid, right? You flip a switch and power magically appears from a plant miles and miles away. But what happens when that distant plant fails? Or what happens when grid demand just pushes prices totally through the roof? Well, we're going to challenge that reliance today. We're exploring how localized energy independence isn't just science fiction anymore. It's a working reality right now. Okay, let's dive right into this. Here's our blueprint for today. We'll start with the anatomy of a microgrid, move into directing the power flow, and then we'll look at two real-world scenarios, community home power and a plaza and lighting setup, and finally, we'll wrap it all up with the economic advantage. All right, part one, the anatomy of a microgrid. Before we can start stringing wires across a neighborhood or powering up a massive office building, we really have to understand the core components that make a microgrid tick. You see, a microgrid isn't just a random collection of solar panels slapped on a roof. It's a highly intelligent, completely self-contained energy ecosystem. And right at the center of that ecosystem is the microgrid controller. If the cables are the nervous system, this thing is absolutely the brain. Think of the controller as the system's vital air traffic controller. It uses AI to constantly monitor supply and demand, making literally thousands of split-second decisions. Like, do we need to pull power from the main grid right now? Should we draw from our batteries instead? Do we have excess solar that we need to store for later? The controller manages all of this super complex logic totally behind the scenes, ensuring your lights never even flicker. Moving on to section 2, directing the power flow. Now, understanding how electricity actually moves through the system is where this gets really fun, and this brilliantly illustrates the whole concept. To make it super easy to visualize, I want you to think about water. Notice the specific paths here. Just picture the yellow solar power lines as rain falling from the sky. Then think of the green and blue battery paths as the pipes leading to and from a massive water reservoir. And that red utility grid line, that's just the municipal water supply acting as a backup. So our microgrid controller is essentially the dam operator. It sees the rain coming in from the solar panels, checks exactly how much water the building needs right this second for things like elevators and AC, and then it instantly directs the flow. It sends it either straight into the building, into the battery reservoir to save for later, or out to the wider city grid. So let's break down the power system engineer's operational logic chronologically. It basically happens in 3 simple steps. Step 1 is generation. That high-efficiency rooftop solar captures sunlight and starts creating clean energy. Step 2 is assessment. The AI controller instantly calculates the immediate load of the building, lighting, appliances, EV charging, the whole shebang. And finally, step 3 is dispatch. The controller routes exactly what's needed straight into the building. Any leftover energy, it routes that directly into the battery storage to charge it up, or it just exports it back to the utility grid. It's just this incredibly elegant, continuous loop of efficiency. Okay, let's move to section 3 and see how this builds in a scenario for community home power. Let's apply that established logic right into a residential environment. If you look closely at this neighborhood, you'll see this isn't just a bunch of random houses that happen to have solar panels on the roof. It's a completely unified network. In a microgrid setup, individual homes actually connect to a shared community energy reserve. So you've got direct current, or DC, flowing smoothly back and forth between the batteries and the homes, working right alongside your traditional alternating current, or AC power flow. Think about it like this. If one side of the street is pulling heavy power to charge up their EVs, while the other side of the street is totally empty and generating maximum solar power, the system just balances it out perfectly. Everyone contributes, and everyone benefits from this intelligent shared power pool. It really creates a stronger, much more resilient community by design. Next up, section 4. Let's look at another scenario, plaza and lighting. But you might be wondering, how does this technology handle heavier, way more demanding commercial environments? Well, let's see how it scales up. Look at these two setups side by side. Over on the left, we've got our quiet residential street, and on the right, a bustling commercial plaza. Visually, sure, the scale changes dramatically. That office building has massive critical loads, we're talking heavy commercial HVAC systems, tons of office equipment, and intensive lighting needs. But the most important takeaway here, the core engineering logic remains exactly identical. That AI controller still assesses the incoming solar rain, measures the building's thirst, and just routes the power accordingly. Now, what's really interesting about this slide is the heavy-duty tech that makes this massive commercial scale possible. See those bidirectional inverters down there? They're the real heavy lifters. They convert the power flow between the huge solar carports, the EV fleets, those high-performance lithium iron phosphate battery systems, and the main grid. And because they're bidirectional, power can literally flow both ways. So the commercial building could actually pull power from the EV batteries if it really needed to, or it could charge them all up when the solar output is peaking. It's just the ultimate flexibility for handling massive power loads. And finally, Section 5, the economic advantage. So all this incredible engineering is fantastic, right? But why are communities and businesses actually rushing to install these systems? Well, it really comes down to the bottom line. So the crucial point here is how these setups actively manipulate power to save serious money. The controller uses this brilliant technique called peak shaving. It basically stores up energy when grid prices are cheap, and then it discharges that stored battery power during peak hours. Exactly when the utility company is trying to charge the highest rates. That reduces your demand charges significantly. Then you've got energy arbitrage, which is basically buying low, generating your own free solar, and using it precisely when it's the most valuable. Combine all of that with the fact that you have instant, totally seamless backup power during grid outages, you're absolutely maximizing your ROI while keeping all your critical operations running without a single hitch. To summarize, the advantages of a microgrid go way beyond just keeping the lights on. We're really looking at the blueprint for a much smarter, greener community. By integrating things like solar carports and smart routing, we enable completely sustainable EV mobility. We're drastically reducing emissions and, frankly, our reliance on aging grid infrastructure. We gain real energy independence and, perhaps most importantly, we guarantee long-term reliability for our homes and our businesses. Which brings us to our final thought for this explainer. The technology is already here, the engineering logic is rock solid, and the economic benefits, they're proven. So will your community remain entirely dependent on the traditional grid, or are you ready to harness the incredible power of a microgrid? I really hope this breakdown empowered you with a clear, straightforward understanding of how these systems actually work. Thank you so much for